This is lesson 6.4, inverses of quadratics. We've talked about inverses before when we talked about linear equations. And so, first of all, let me remind you of what the quadratic parent function looks like. It's y equals x squared, and it's this parabola. And I want to point out a couple things. Notice that, of course, the parabola goes through 0, 0. It also goes through 1, 1, and negative 1, 1, and 2, 4, and negative 2, 4. And I want to point those out because in a little bit we're going to find the inverse, and I want to show you how that compares. So y equals x squared is our quadratic parent function, so we're going to start by finding its inverse. To find the inverse of any function, quadratic or otherwise, the first thing you do is switch the domain and the range. Well, what that really means for us is we're going to switch the x with the y. So wherever my y term is and wherever my x term is, I'm going to flip-flop them. And then we're going to solve it for y, which means to get y by itself. Okay? So let's try an example with this. If I have y equals x squared, and I'm going to find its inverse, I'm going to start by switching the x with the y. So now I have x equals y squared. The second step is to get y by itself, and since y is squared, we will square root both sides. So we get y is equal to the square root of x, and remember whenever we do a square root, we also have plus or minus. So now I'm going to graph this. When I say y equals the plus or minus square root of x, it means y equals the square root of x and y equals the negative square root of x. Well, the positive square root of x looks like this right here, and the negative square root of x looks like this right here. And you can see how together the y equals the square root of x and y equals the negative square root of x makes a sideways parabola. So let me point out to you, when you're talking about inverses, inverse functions have a symmetry that goes across the line y equals x. So the dotted line that I've drawn in red is y equals x, and you can see how if we were able to fold this picture along the red dotted line, my two graphs, my green and purple graphs, are going to line up. Now remember that an inverse means that the domain and range are opposite. So when the green graph has the point 2, 4, the purple graph is going to have the point 4, 2. And you can see right there in drawing it, I just missed it a little bit. But see, this was 2, 4. And now down here, this one is 4, 2. And we can look at some other places, like when we have this point over here at negative 1, 1. Negative 1, 1. Well, if we switch those, we go to 1, negative 1, which is right here. So anything that you have on the green graph, if you switch the x and y values, you're going to get the purple graph. And then they have the symmetry that goes along the line y equals x. Okay, so let's do another example where we're going to find the inverse. To find the inverse, you're going to take the y and the x and you're going to switch them. Well, if you don't have a y, remember f of x is y. So this is the same thing as saying 1/4 x squared minus 1 is equal to y. So we're going to take the y and the x and we're going to switch it. So that's going to be x equals 1/4 x squared minus 1. Now, not 1/4 x squared. That's 1/4 y squared. Now we're going to try to get y back by itself. So the first thing I'm going to do is add 1 to both sides. So this is going to give me x plus 1 equals 1/4 y squared. And then to get rid of the 1/4, I'm going to multiply both sides by 4. Multiply both sides by 4. So that's going to give me y squared equals 4x plus 4. And then one more step to get y squared by itself, I have to square root both sides. So when I square root 4x plus 4, that will give me y. and that's going to be the inverse function for 1/4 x squared minus 1. These two functions will be inverses. So remember, we added the 1 first, we multiplied by the 4 second, and then we did the square root of both sides to get our solution. Okay, the next type of problem is going to be verifying inverses. When you verify two inverses, you find these two combinations. The first one is called f of g of x. The second one is called g of f of x. I'm going to show you how to find both of those. And when you find both of them, if you have inverses, then both of those answers, f of g of x and g of f of x, should both equal x. If you get x for each of them, then you know you have inverses. So here's what an example of this would look like. Okay, so first we're going to do f of g of x. And what that means is I'm going to take what g of x is equal to, and I'm going to plug it into the x of this function. So for f of g of x is x squared, so instead I have x squared. Now I don't want that x to be there, so I'm going to take the x out, and in its place I'm going to put the square root of x. So I'm taking the square root of x and putting it where the x part was of my function. So now what I have is the square root of x squared. So if you recall, what happens when you take a square root of x and you square it? The squaring cancels the square root and you just get x. And remember that our goal is to have both sides, both f of g of x and g of f of x, we want them both to equal x. So far f of g of x worked. Now let's do g of f of x. We're going to do the same thing, except for this time we're going to switch places. So this x right here, this x squared, the whole thing is now going to go into just where this x is here. So g of x equals the square root of x. But where the x is, we're going to replace that with x squared. And if you do the square root of x squared, the square root cancels the x squared and you get x. So since plugging the g function into the f function gave us x, and plugging the f function into the g function also gave us x, then these are inverses. And hopefully we already knew that because that was one of the first inverses we found in this video. So let's try a problem that's going to be a little bit more challenging, we'll say. So let's do f of g of x first. Okay, so here's my f function. It's 5 times something squared minus 2. In the original function here, it's 5 times x squared, but we're taking the x out and we're going to replace it with this whole function. Okay, so let me see if I can squeeze this in here. X plus 2 over 5 to the 1/2 power, and then it's now squared and then minus 2. So what happens if I multiply 1/2 times 2? Since we have a power to a power, if I multiply 1/2 times 2, then that you just get 1, right? So if the exponent is 1, we don't actually have to write it. So now this is 5 times x plus 2 over 5 to the first exponent, but we're not going to write it, minus 2. And then now look, these 5's are going to cancel each other. So I'm left with x plus 2 minus 2. And plus 2 minus 2 cancels each other, and we're left with x. So that's the first verification. We have verified here that f of g of x equals x. So now I'm going to erase this and we're going to go back the other direction. This time we're going to find g of f of x. So g of f of x. Okay, so the g of x function over here, Erase some of that without messing it up. The g of x function over here is equal to something is x plus 2, so I'm going to leave this part blank. Something plus 2 divided by 5 to the 1/2 power. So then in this open space here that I left, this open fraction, open parentheses, we're going to replace that with 5x squared minus 2. 5x squared minus 2. Okay, now I want to simplify this. So I have 5x squared minus 2 plus 2 minus 2 plus 2. All I did in this step is remove. I took these parentheses and I took them away. So 5x squared minus 2 plus 2, well, the 2's are going to cancel. After the 2's cancel, I'm left with just 5x squared over 5. 5x squared is right here over 5. The 2's are gone, remember. So what happens if I divide 5 by 5? 5 divided by 5 cancels. And now what I have is x squared, parentheses, 1/2 power. Now when you have power to a power, we multiply these two powers. So 2 times 1/2 just gives me 1. So x to the first power is just x. So now I've verified that g of f of x is equal to x. So since both of my functions worked, g of f of x and f of g of x both equal x, then these are indeed inverses. Okay, so you don't have to verify on this one. This is your on your own problem. And the only thing I want you to do is find the inverse. So you remember this is your initial problem, y equals 6x squared. And you're going to start by taking the y and the x and switching them, and then get y by itself.